In episode 1, we use demo actors. In this episode, we build one from scratch, so you understand exactly what is in it and why. By the end, you will have a custom actor entering the turn order, able to move and attack. An actor is a prefab with a specific set of components. Some are mandatory. The system cannot function without them. Others are optional, activated by a profile asset. We will go through all of them. We will focus on the 3D pipeline. Creating 2D actors is not that different. Both use the same components and only differ visually, so most of what you learn here applies to 2D as well. The fastest path is the wizard. Go to TBCS in the menu bar, then click Create Actor Prefab from FBX. This opens the new actor wizard. Click the Browse button next to the FBX model field. This opens a picker filtered to FBX files. Select your model. I will use a simple humanoid. Once loaded, a live preview appears on the right that you can orbit and zoom. Notice that Create stays disabled until a model is loaded. The wizard has 3 tabs: Actor, Components, and Output. On the Actor tab, set a name. I will call mine Knight. Size stays at 1 for a standard character. Size 2 means a 2x2 footprint. Below that, set faction. Friendly for player characters, hostile for enemies. Still on the Actor tab, toggle Add Hand Sockets on. This creates weapon attachment points from the humanoid rig bones. It only works if the FBX avatar definition is set to humanoid. If the rig is generic or none, the wizard cannot locate the hand bones and sockets will not be created. Click the Components tab and set Component Set to Full. This auto-loads the components prefab, actor profile, animator controller, and animation mapping. Everything for a fully featured actor with animation. Core loads a slimmer prefab without animation. 2 collapsible sections below let you inspect what was loaded. The animation setup shows the animator controller and animation role key mapping, both filled with stock defaults covering idle, walk, attack, cast, hit, and death. The defaults are exactly what we need. Choose a health system from the dropdown. It must match the health factory in Bootstrap. Then click the Output tab, pick the Save folder, and click Create. Open the Knight prefab and look at the inspector. This is the full component stack. Let me go through each one. The actor component is the identity. It tells the system this object is a combat participant. It must sit on the root, never on a child. Size is what you set in the wizard. Blocks movement and blocks vision control whether the actor blocks pathing and line of sight. Both default to true. The state flags is alive, is moving, is guarding, is targeting, has committed. Our runtime state the system toggles during combat. Useful for debugging in play mode, but not meant to be set on the prefab. Faction drives targeting. Portrait is an optional icon for the turn order display. Base initiative controls turn order. Higher values act earlier. We will see this when we test. The component profile slot references the profile asset that gates optional components. We will cover that after the walkthrough. The actions component owns the actions this actor can perform and the action points pools that fuel them. It has 2 fields. The movement component handles pathfinding and movement execution.
Movement speed and rotation speed control how fast the actor visually moves and turns.
They do not affect how many cells the actor can reach. That is driven by action points. Facing direction is the starting orientation, updated automatically during combat. Movement points reference is the key field. It tells the component which action points pool to check when calculating range. It must match the pool that step costs from. If they mismatch, the preview will be wrong. The system logs a warning if it detects this. Below this component is the movement animation controller, which drives walk and idle animations based on whether the actor is moving. The pathfinding component calculates reachable cells, costs, and path validity. The movement component calls into it. The inspector fields are internal runtime state. You do not configure anything here. The attack component handles weapon attacks, range checks, line of sight, and dispatching to the combat rules. Extra attacks defaults to 0, meaning 1 attack per turn. Raise it for multi-attack builds. Preview as circular ring controls how attack range displays on the grid, as a smooth ring or as highlighted cells. The remaining fields control projectile spawn and aim positions. Projectile spawn lets you assign an origin transform. If left empty, the system auto-detects from the rig. The offset and height fields fine-tune positioning. The defaults work for standard humanoid models. The reaction component handles opportunity attacks. It has no configuration fields and reads everything from other components at runtime. It requires a reaction attack action and a reaction points pool, both included by default. The actor behavior connects to the AI system. Leave AI empty for player-controlled actors. Assign an AI asset for AI-driven actors. We cover AI in Episode 6. The actor state machine tracks which state the actor is in: waiting, moving, attacking. A state name field shows the current state at runtime for debugging. The status component tracks active status effects: stunned, poisoned, and so on. The inspector shows debug lists that are read-only runtime state. We will use this in Episode 8. The animation child object holds the animation driver, the bridge between the combat system and the Unity animator. It plays combat animations using a role-based mapping system. The animator, base controller, and role key mapping fields are what the wizard filled in. The driver reads them at runtime to decide which clip to play for each action. The timeout fields are safety nets. If an animation fails to start or finish, the system times out and moves on. On the visuals child object are two presentational components.
The highlight component drives the selection indicator ring and rim lighting around actors. Self, friendly target, hostile target, and threat, one color per context.
Model container points to the renderers. The selection indicator controller manages the ground ring beneath the selected actor. Sizing, height, pulse, and rim glow. The defaults look good out of the box. One more component to know. The voice component plays combat sounds, hit reactions, turn barks, death cries. It is not in the default prefabs but can be added manually. The prefab ships 4 optional extension components, all gated by the actor component profile. The inventory component gives the actor an item container. The equipment component manages weapons and gear. Right-hand socket and left-hand socket are bone transforms for weapon attachment. Unarmed template is the fallback weapon. Weapon sets holds loadouts the actor can cycle through. The stats component owns numerical attributes: strength, speed, armor. It references a stat definitions collection. The abilities component manages abilities at runtime, referencing an ability definitions collection. Disable any of them in the profile and the system ignores them cleanly. Now let us look at the 2 key fields on the actions component in detail. Because we selected full, both are already configured. The action templates field references the default action definitions collection, which ships with 7 actions. Move cues a movement path and is free by default. Step is the per cell action that move cues internally. Its cost comes from the terrain. Attack performs a weapon attack costing what the weapon defines. Extra attack is queued automatically when extra attacks is greater than 0. Defend puts the actor in a defensive stance and ends the turn. Rotate turns the actor to face a new direction. Reaction attack fires on opportunity attacks, spending reaction points instead. The toolkit ships additional action types you can add to a custom collection: swap weapon set, ready action, modular cast, and reaction cast. The action points list has 2 pools. Standard action points with a base value of 5 is the shared pool. Move itself is free. The cost is per step.
Attack has a fixed cost of 1 by default, but action definitions can also pull their cost from the weapon at runtime using contextual mode. So 5 points might cover 4 cells of movement plus an attack, or all 5 on movement alone.
Reaction points defaults to 1. It is spent on opportunity attacks and is separate from the standard pool. Using it does not end the turn. Each pool references an action points definition asset. You can add more pools. a dedicated movement pool, a mana pool, whatever your game needs. The default values are starting points, not limits. The actor component profile is a scriptable object that controls which optional components are active. The actor component has a component profile slot. Full is already assigned from the wizard. The profile has 4 toggles: use inventory, use equipment, use stats, and use abilities. Full enables all 4. For a simpler enemy, create a custom profile with the relevant toggles off. Core disables all 4.
Now, let's add our actor to the scene.
Drag the knight prefab into the scene and parent it under Grid Manager, inside the object's container. Actors outside this hierarchy are not found by the grid system. Position it over a grid cell, then go to TBCS, Grid, snap to Grid to register it. Manual placement works for quick iteration. The cleaner workflow is the spawner from Episode 1. Add the prefab to the spawn list and let it handle placement at startup. Press play. The knight should enter the turn order. If it does not, check the console. The 2 most common problems are: the actor is not snapped to a grid cell, and the action definitions collection is missing. If you see a null component warning, check whether the component exists and whether the profile is disabling it. The profile gates inventory, equipment, stats, and abilities. You now have a complete custom-built actor. You understand what every component does, how action points pools work, and how the component profile gives you per-type feature toggles. In Episode 4, we look at the 3 global data assets: the settings asset, turn manager settings, and the combat rules asset, and understand how they shape the feel of combat before a single roll is made.